Okay, so today we're going really local and diving deep into the future climate of one specific place. It's Niamey, the capital of Niger.
Yeah, really getting granular.
Exactly. And the source material we have is fascinating. It's actually a student project called Math 3001 Project in Mathematics. It's by Jonathan Khabusi.
Really interesting stuff.
Yeah, it is. And basically what he does is he takes these two very sophisticated climate models and projects, what they predict for Niamey decades into the future, late 21st century.
Out to 2100.
Exactly. And we're talking about rainfall, those all important dry spells, changes in temperature, wind patterns, the whole nine yards. But the real mission for us today is to pull out the insights that are going to be especially useful for anyone involved in agriculture in the region.
Yeah, because of course, agriculture in Niamey is hugely dependent on rainfall, you know?
Hmm.
So understanding how that might change is really key.
It is a huge deal. And the main crops there are millet and sorghum,
Oh,
very much tied to how much rain falls and when it falls. So understanding those dry spells, that's critical knowledge for anyone connected to the region.
absolutely.
So let's just jump right into it. First, can you give us a quick overview of these two climate models we're dealing with, CB4 and R25? What are they all about?
Sure. So CP4 stands for Convection Permitting for Africa, and it's what we call a high-resolution model. It uses a grid of just 4.5 kilometers, so it's able to explicitly simulate those really powerful thunderstorms that happen in the region.
Wow, 4.5 kilometers. That's pretty tight.
Yeah, it gets down into the details, and then you've got R25, which has a 25-kilometer grid, so it's a bit more coarse.
Hmm.
It doesn't resolve those individual thunderstorms in the same way, it kind of represents them more broadly using mathematical equations.
Got it. So CP4 is giving us that very close-up view, almost like a magnifying glass on those storms, and R25 is taking more of a regional perspective.
Exactly, and the fascinating thing is that the project actually tested both of these models against real-world data from Niamey.
Okay, so they had something to compare to.
Yeah, they used 10 years of data from 1997 to 2006 from the AMATCH Observatory, which is right there in Niamey, so it's a really good comparison.
So they could see how well these models actually reflect what's been happening on the ground.
Right, and what they found is that neither model is perfect on its own, but by averaging the results from both models, you actually get the best picture.
Interesting. So it's kind of like getting a second opinion from a doctor.
Yeah, you get a more well-rounded perspective, and it helps fill in gaps where the observational data was maybe a bit sparse, particularly during the dry season.
Okay, that makes sense. So we're really taking the best of both worlds here now.
Yeah.
Let's talk rainfall because that's obviously the lifeblood of agriculture in Niamey. What did the models show about how much rainfall varies from year to year, both now and into the future?
Well, both models show that annual rainfall can really jump around what we call high interannual variability, and that's true both for the current period they looked at and the future projections.
So even if a total rainfall over a long period is going up or down, there can still be these big swings from year to year.
Exactly, and what's interesting is that they found the correlations between how CP4 sees that year-to-year variability compared to R25 were statistically insignificant both for the current period and for the future.
So even though they both show variability, they don't necessarily agree on which years will be wetter or drier.
Right, so if you're a farmer trying to plan for a specific year way in the future, that's pretty tough to do based on these models.
I can imagine, and it gets even trickier because they found that even within each model, if you compare its past predictions to its future predictions for annual rainfall, the correlations are also very weak.
Yeah, so predicting the exact amount of rain in, say, 2095, that's a really tall order.
Okay, so pinpointing a specific year's rainfall is probably not going to happen.
Yeah.
What about the bigger picture? What are the models saying about the overall trend in rainfall? Is it going up? Is it going down?
Well, here's where things get a bit more clear-cut. Both models project a substantial increase in manual rainfall. By the end of the century, we're talking a pretty significant jump.
Okay, so more rain overall, but how is that extra rain going to be distributed? Will it change the timing of the wet and dry seasons?
This is good news for agriculture because the overall monthly pattern of rainfall actually stays pretty consistent across all four model scenarios, current and future, for both CP4 and R25.
So the basic rhythm of the seasons is still there.
Yeah, you still have that peak rainfall in August and that long dry season from November to March or April, driven by the Harmattan winds.
Okay, so the timing of the rainy season stays roughly the same, which has got to be good for planning purposes. But what about the amount of rain within those months? Does that change?
The project found a very strong positive correlation between current and future monthly mean rainfall for both models. So what this means is that while the total amount of rain in a given month might go up or down the timing of when that rain falls when the wet season starts and ends, that's likely to stay pretty much the same.
That's huge for farmers that predictability is gold.
Yeah.
You did mention that there were some differences between the two models, specifically for June and July. Can you talk about that a bit more?
Yeah, CP4, the high-resolution model, tends to show a bigger increase in rainfall during those early rainy season months compared to R25.
Interesting. Why do you think that is?
Well, it could be because CP4 is better at capturing those intense early monsoon rains that kick off the wet season.
Mm-hmm.
Yeah, R25, with its broader perspective, might smooth out some of those details.
Okay, so some potential nuances there. Now let's switch gears and talk about the other end of the spectrum, those really intense downpours. What did the models say about the risk of extreme rainfall events in the future?
Yeah, so the project defined an extreme rainfall day as one with more than 60 millimeters of rain. And looking at the historical data, CP4 showed only 2 of those days per year on average, while R25 showed 3.
Okay, not a ton, but what about in the future?
Well, this is where things get interesting. By the end of the century, CP4 is projecting a whopping 18 extreme rainfall days per year on average.
Wow, that's a huge jump.
Yeah, a massive increase. And R25 also projects an increase, but it's much smaller, only up to 7 days per year.
So a big difference between the two models there, but either way, it sounds like the risk of flooding in Niamey is definitely something to be concerned about.
It is, and the project discusses the potential implications for infrastructure and agriculture, but it also highlights a possible silver lining. With more intense rainfall, there could be opportunities to capture and store that excess water in reservoirs, which could then be used during those dry periods.
So turning a potential problem into a potential solution, very interesting. Now let's talk about the flip side of those intense downpours, dry spells. What did the models project about how those might change?
Yeah, this is where we see some really interesting discrepancies between the two models. So the project defined a long dry spell as any period with less than 1 millimeter of rain for more than 10 consecutive days. And when they looked at the probability of those long dry spells happening during the rainy season, the models actually disagreed on the direction of change.
Really? So,
R25 suggests that longer dry spells will become more frequent in the future, which would be a big problem for crops. But CP4 actually indicates they might become less frequent.
okay, so two very different takes on that one. Is there any reason to think one model might be more accurate than the other in this case?
Well, the project did some statistical testing to see how well each model's current predictions for dry spell frequency match up with the actual observed data, and they found that R25's predictions were a better fit with the historical data.
Interesting. So that might lend some more weight to R25's projection of more frequent, longer dry spells in the future.
Yeah, something to keep an eye on, and just to add to the complexity, they also looked at shorter dry spells, those lasting 10 days. And in that case, CP4 predicts an increase in the future, while R25 predicts a decrease.
Wow, so lots of conflicting signals there. It really highlights the importance of considering both models and not just relying on one. Now, I want to get into the nitty-gritty of how a typical rainfall event unfolds according to these models. Can you walk us through that?
Yeah, they did this cool analysis where they basically looked at the average hourly rainfall patterns in the hours leading up to, during, and after a typical rainfall event. And across all the scenarios, current and future, both models, they found a pretty consistent pattern, very little rain in the 6 hours before the event. Then a brief lull, followed by a sudden burst of really intense rainfall.
So kind of like a switch flips and the skies open up.
Exactly. Now, the main difference between the models comes in the hours after that initial burst. CP4 shows that the rainfall actually increases for another hour after that initial peak, and that it gradually declines over the next 3 hours or so.
So a more sustained period of heavy rain.
Yeah, and they define useful rainfall as at least 1 millimeter per hour, and CP4 suggests that lasts for about 3 to 4 hours for a typical event. R25, on the other hand, shows the rainfall intensity dropping off immediately after that initial peak, and the useful rainfall only lasts for about 2 hours.
Interesting. And how do these patterns compare to what's been observed in reality?
Well, when they compare the model results to the actual hourly rainfall data from Niamey, they found that the overall shape of the rainfall event was more similar to R25, that immediate drop-off. But the length of the useful rainfall period was closer to what CP4 predicted, around 3 hours.
Okay, so again, each model capturing different aspects of the reality on the ground. It's fascinating. Now, the last piece of the puzzle here is how rainfall interacts with temperature and wind. What did the model show us about that?
Yeah, this gets really interesting. So starting with temperature, CP4 shows a pretty consistent pattern with the temperature rising in the hours leading up to the rain and then dropping sharply just before and during the rainfall. And the average temperature around rainfall onset is projected to be about 6 degrees Celsius higher in the future.
Wow, 6 degrees. That's quite a jump.
Yeah, and R25 also projects a similar increase in future temperatures. But the pattern is a little different. It shows the temperature peaking about an hour before the rain and then cooling more gradually.
So similar overall warming, but slightly different patterns now. How might that temperature increase impact those key crops, millet and sorghum?
Well, both of those crops have a preferred temperature range,
Yeah.
somewhere between 26 and 30 degrees Celsius. So a 6-degree increase could push things outside that comfort zone. And that might mean farmers need to consider more heat-tolerant varieties in the future.
That makes sense, adapting to the new reality now. What about wind? What did the models tell us about that?
So looking at the UN, which is the east-west component, CP4 projects stronger future wind speeds leading up to rainfall. The pattern itself is fairly consistent between current and future scenarios, and there wasn't really a statistically significant correlation between U-wind and rainfall. R25, on the other hand, shows the east-west wind peaking a few hours before the rain and then declining steadily, and in the future projections, there's actually a weak negative correlation, meaning that as rainfall increases, the east-west wind tends to decrease.
Okay, so some differences there. What about the north-south wind, the V wind?
For V-wind, CP4 shows the strongest speeds happening right around when the rain starts, and there's a moderate positive correlation. So stronger north-south winds tend to be associated with more rain, and that's true in both the current and future projections. R25 shows a different pattern, with the weakest north-south winds happening before the rain, and then a peak later on, and in the future projections, there's a weak negative correlation. So stronger north-south winds are associated with less rain.
So again, opposite patterns between the two models. Very interesting. Finally, what about the overall wind strength?
In CP4, the wind magnitude peaks right around the onset of rainfall, and there's a weak positive correlation. But in R25, the strongest winds happen before the rain starts, and there's a moderate negative correlation, so the wind tends to calm down as the rain intensifies.
Okay, so some really different interpretations of how wind and rainfall are connected. Does the project offer any insight into which model might be more on target here?
They do. They also looked at the correlation between wind speed and temperature, which provides some useful context. CP4 shows a strong positive correlation suggesting that stronger winds are colder, while R25 shows a weak negative correlation meaning stronger winds are warmer, which is the opposite of CP4. And based on that, the project suggests that CP4 might be a more realistic representation for Niamey.
Okay, why is that?
Well, the typical West African monsoon brings in warm, moist air from the Atlantic, but that air tends to cool down after the rain starts. So CP4 is showing colder winds with heavier rainfall that aligns better with how we understand the regional climate.
Got it. So CP4's projection of stronger, colder winds accompanying rainfall in the future. That's something to pay attention to.
Absolutely. It could have big implications for livestock and agriculture, potentially more challenges for farmers to deal with.
This has been a super detailed deep dive into some fascinating research. Can you just give us a quick recap of the key takeaways for our listeners?
Sure. So the big picture is that both models project an increase in total rainfall for Niamey by 2100, which could be a good thing. But the risk of extreme rainfall events and flooding, that's also going up. And the models disagree on how those crucial dry spells might change in the future. And when we look at the combined effects of rainfall, temperature, and wind, it seems like we be in for some more intense weather events with heavier rainfall and stronger, colder winds, at least according to CP4.
And the main message is that we really need to look at both models to get a complete picture.
Absolutely. Each model has its strengths and weaknesses, and by considering them both, we get a much richer understanding of the possibilities.
So for our listeners out there thinking about Niamey's future, all of this raises some big questions. How do you plan for these potential changes in rainfall, these more intense weather events? What kind of adaptations do farmers need to make to their practices? And what about infrastructure? Can it handle these potential increases in flooding and stronger winds? It's really a call to action to start thinking proactively and planning for these shifts.
Absolutely. And it's important to remember that these are just projections based on our current understanding. Climate science is always evolving, and we're constantly refining our models and our predictions.
Very true. Well, thanks so much for walking us through this fascinating deep dive.
My pleasure. It's been great discussing this important topic.
Absolutely.
And I think it really highlights the need for continued research and attention to these local climate impacts.
Couldn't agree more.
Because ultimately, it's about helping communities like Niamey be prepared for the future.
Exactly. Well said.
All right. Thanks again for having me.
Of course. Thanks for coming on.
Bye.
See ya.